So hello everyone, myself Kalzong lepcha of Namchi Government College, BD roll number 21NS0242, BSc third semester. So today I'm going to share my slides on topic sonometers. So further I would like to highlight my content. Thank you. So in my present So first of all, here is the definition of sonometer. A sonometer is an audiometer which is used to measure the sensitivity of hearing, or it is a device that is used for demonstrating the relationship between frequency of the sound that is produced by strings when it is plucked and the tension, length and mass per unit length. This tuning device is first invented in 1694 by Etienne Lully to facilitate the tuning of the stringed instrument. So you can see the diagram of sonometer in the screen. So talk about the construction of sonometer. A hollow box 1 meter long is used for making the sonometer. This hollow box consists of uniform metallic strings attached to it. The first end of the string is connected to the hook while the second end connected to the weight hanger with the help of pulley. The number of strings used is 1 and there is known as monochord. In order to increase the tension string, weight are added at the free end. To change the vibrating length of the string, which is stretched, two adjustable knives are placed and positions are adjusted accordingly. So here is the method to resonate the sonometer. There is three methods by which a sonometer can be made to resonate. Number one method is stationary wave method. We place a paper strip between the two fixed movable bridges, then place the tuning fork and adjust the distance between two bridges until the paper strip falls off the string. And second method is beat method. Plug the string between the two bridges, then keep the tuning fork and move away the movable bridge until the number of beats reach the minimum. Third is by the listening of change of frequency. Listening to the pitch of the sound emitted by the fork in ear, then plug the string between the two bridges and move the movable bridge until you hear the similar pitch. So here is the working of sonometer. Once a setup is done as shown in the diagram in previous slide, a transfer stand wave is produced at the edge of the knives with notes. Along with the notes there is the formation of antinodes. The mathematical explanation of the working sonometer is as follows. So here L is the length of vibrating element, F is the frequency of the element, and T is the tension created by the strings, and mu is the mass per unit length. Then if the rho is the density of a material and d is the diameter of a string, the mass per unit length mu is given as area into density. So then hence the frequency of the sound produced by unknown strings when it is plucked is given by this following equation. Law of transverse vibration. So the law of transverse vibrations on the stretched string can be divided into three laws, and they are law of length, law of tension, law of mass. Law of length. The law of length states that the frequency of vibration of a stretched string and its resonating length varies inversely as long as the mass per unit length and the tension of the string is constant. We can show the law of length by plotting the graph of frequency versus reciprocal of length. To perform this experiment, we have to keep the tension and the mass per unit length constant. So, arrange the sonometer and place paper strips between the two bridges. Then, use the tuning fork beating with the high frequency and keep it on sonometer box. Then, adjust the distance between bridges so that some distance the paper falls. Then measure the distance between the two bridges. Repeat the experiment with the other forks in the sequence of decreasing order of their frequency and record the minimum length required to remove the paper strip of the string. So here is the experimental setup. You can see in the diagram. Then the plot of frequency and the reciprocal length will be linear as shown below, which shows that frequency is inversely proportional to the length. Now the law of tension. The law of tension states that the frequency of vibration of the stretched string and the square root of its transverse of its tension varies directly as long as resonating length, and the mass per unit length of the string is constant, showing that F is proportional to root of T. To perform this experiment, we have to keep the length and the mass per unit length constant. So arrange the sonometer and place some paper strips between two bridges, then use the tuning fork beating with the highest frequency and keep it on sonometer box. Then keeping the distance between the bridge constant, adjust the tension by adding mass and record the weight or tension needed to remove the paper strip of the string. Repeat the experiment with the other forks in sequence of decreasing order of their frequency and record the minimum tension or the mass required to remove the strips of the string. Then plot the graph between frequency and the tension. If the graph is linear in the form of y is equal to mx, we can conclude that f is proportional to root t. So here is the plot of frequency versus tension. So, law of mass. The law of mass states that the frequency of vibration of a stretched string and the square root of the mass per unit length varies inversely proportional as long as the length and the tension is constant, showing that F is inversely proportional to the root m. To perform this experiment, we have to keep the length and the tension constant. So, from the formula, you can see in the screen. To this experiment, we have to arrange the sonometer and place some paper strips between two bridges, then use the tuning fork beating with the highest frequency and keep it on the sonometer box. Then keeping the distance between the two bridges same, we use different string various mass per unit lengths and record the readings needed to remove the paper string of the string. Then plot the graph between f and 1 by root m. If the graph is straight line in the form of y is equal to mx, we conclude that f is inversely proportional to the root m. So we can also do this experiment by using the string connected parallelly across the bridge. Then by changing the first string with some other string which have different m values, we can measure the minimum length that is required in the second string to be adjusted to make the system resonate. Now, application of the sonometer. So as I already mentioned that a sonometer is used for demonstrating the relationship between frequency and the tension, length and the mass per unit length of the string. Therefore, the following can be determined by the use of sonometer: the frequency of the tuning fork, the frequency of alternating current, the tension of the string, and the unknown mass of the object hanging down. Thank you.